Okay, it's already 5 p.m. Welcome back to the tutorial session 4 of Nuclear Astrophysics. But as very few people have joined, and we should wait few minutes for letting other join. Let us wait for a few minutes then. Then I will start. Okay, let us start now. In the due time, people will join. I'll add them and they will join the course. Few people told that they will be late to join the course, today's discussion session. So maybe that's why they're late. And yes, so let us start today's discussion. Before that, okay. Yes, today let all you guys welcome in week 4 discussion. Uh, this is week 4, tutorial 4 of Nuclear Astrophysics course by NPTEL. The course instructor is Professor Anil Kumar Godishetty and myself Nilakshi, as you all know. And we'll have a problem solving and doubt clearing class every Saturday 5 to 7 p.m. So we have already reached to the 50% of this course. Today is the week 4, and after today's class we'll left with only 4 more class. And by now I think you guys all have a pretty good understanding that what you are going to learn in this course, and what you are learning, and what will be the outcome of this course, what we expect that you get to know, and what will be the question format, assignments, how the problem solving sessions will help you. All these they are clear to you by now. And today's session will mostly be like solving the problems, because the assignment 4 of your course was pretty much difficult than the assignment first, second, and third. So as we have discussed, and we thought that maybe it will be more helpful to you if I solve those questions in front of you, so that you can get the glimpse at how to solve these kind of questions. Because let me clear you guys that you are going to get this kind of question, and these week 4 assignment was a proper numerical answering type question paper. So these are the sample examples for you, such that you will be able to solve problems during your final examination. These assignments are for these assignments you need to solve 6 assignments at least out of 8 assignments, so that you get the chance to give the examination. But the marking scheme and what will be your score, all those will be mostly dependent upon the last and final examination. So these problem solving sessions and our motive is to prepare you guys such that you perform well there, and you also get the proper idea and proper understanding of this subject. So that's why this is much more important to get to know that what kind of question you get in this assignment 4, those are very clear to you. And these are not very short answer type questions. You need to solve this question rigorously to get the answer properly. And you can write in chat box that how many of you were able to solve this assignment 4 of this course with very much confidently. Because this if you can solve this type of question, then you will perform surely very good enough in your final examination. But yes, obviously the process, sometimes this happens in case of numerical answer type questions, we guess, but guessing is not always the right process, and we need to know that how to solve exactly these questions such that we don't get stuck in final examination. So let me go to the today's discussion topic and what have covered already in the week 4 lectures, those things without uh, taking much time in this. And yes, obviously, as I always tell, that every this session will be uploaded in official channel of my with the NPTEL. And that channel link maybe I can share again with you, those who want to visit it again and check the this discussion session, or somehow missed this discussion session and want to check it, they can go to this YouTube channel. I'll upload this here, and you'll be able to see the discussion session also. And last but not the least, ask the questions. If you find any doubt in the ask a question portal, we are there for you. Or you can already also discuss in this discussion session. Many of you do so, I have seen in the previous discussion sessions. And you can write in the chat box also, or by also can you can tell by unmuting yourself. So yes, These are the basic things that I used to tell every time, every day, to when I start the discussion session. But yes, in this today's discussion, I will cover up all those things that I told you guys in previous class, that I will tell about these things. And the main thing is today, and the best time to do is that best time to do is the tunneling thing. Many of you have mailed me, and I have seen in the Ask a Question portal also, that what is quantum tunneling and why we are discussing about quantum tunneling, and what is the importance of it, and so on and so forth. So I will discuss about quantum tunneling, and this is a perfect time to discuss about the quantum tunneling also, because after that it will be so late to discuss about this. And in these week 4, I have seen that there was some involvement with the quantum tunneling perspective also. So yes, let me start with our discussion today. The week 4 content was non-resonant charged particle induced reactions, then astrophysical S-factor, and non-resonant charged particle induced reactions again, and then the Gamow peak and electron screening effect, and resonant reactions, and that continued in the lecture 20 also. So these lectures are this time, these in these lectures, the resonant reaction and reaction rate is covered pretty well, and very it is been elaborated in some sort of deep manner. So I will not discuss anything about resonant reaction and reaction rate, all those things, though I have discussed about reaction rate in the previous class, and I will solve the questions. And please make sure that this assignment 4, what you have got for this time, week 4 assignment, you understand that properly, and you solve those every problems by yourself. I will solve these questions for you today, such that you don't stop in the final examination, and you get the proper idea how to solve this. And now the key concepts to learn today. Obviously, we will discuss about Gamow peak, Coulomb barrier, reaction rate, and main thing problems. This will be miscellaneous problem, and mostly from your assignment 4, which you have already submitted. And but first, I will discuss about the photodisintegration S-factor cell model, because I wanted to continue cell model. I already gave you some problems, some nuclei to find out their ground state. I hope you guys all have done that, and I will ask you people that what the answer you have got, those who have done. But before that, let other people join also in between this time. I will discuss about photodisintegration and S-factor. Then I will ask that what answer you got for the previous day's homework. I gave you this homework that find the ground state for 43 calcium 20, 7 and 7 nitrogen 13, and 5 boron 11. So what will be the answer? You can also calculate it now, because I discussed about how to find out the ground state for even odd and odd nuclei in very elaborative manner, and I hope everybody of you have understood that by now. If anybody has any doubt regarding this ground state calculation of any of the nuclei, then please let me know. And I will obviously solve these homework problems for you again today. But before that, let me start today's discussion session with the photodisintegration. So photodisintegration, as you can see in the slide, that it occurs when a high energy photon is absorbed by an atomic nucleus. The nucleus splits to form lighter elements, such that it releases neutron, proton, and alpha particle. That you can see that if an energetic photon is coming and it is falling on the iron nucleus, and it neutrons and the He4 nucleus, that is the alpha particle, those are coming out of it. So this is just what is called the photodisintegration process. Nothing more than that, and you just need to have this notion that what is photodisintegration, that so that you can visualize that if somebody told photodisintegration is happening, that you have the notion that energetic some photon is coming, and the nucleus is breaking, and it is producing some sort of fundamental particles like neutron, proton, and alpha particle. So by even if I give you some reaction, by seeing that also you can understand that this is a photodisintegration process. Let me write it here. Photodisintegration. The reaction can be written as like gamma. Gamma, you know, gamma means photon, and it is coming to iron, that is 56 Fe. Then it is producing 13 4He plus 4N. This is one example, or even you can write it another example like 4He. Now another, not is it is not an another example, but now there are 4He. It can even be splitted into neutron and proton again. So it will be now 2p plus p plus, because it is positive proton, and 2n neutron, it is neutron. So this is a photo disintegration equation such that you can understand. So you can write these as Fe gamma. Gamma is falling, that is it is falling to the target. Target is Fe56, and now on a projectile is gamma, and it is producing 4n and 13 4He. That is a reaction. By seeing this, you should be able to tell that you should be able to tell that this is a photo disintegration process, because any photo disintegration process, that the target particle target nuclei will be some heavier element, and the projectile through which will be bombarded, that is the gamma, that is a photon, energetic photon. So energetic photon is coming, is falling over the heavier nuclei, and it is producing alpha particle, neutron, proton. So that is what it called photodisintegration process. So that is the photodisintegration process, but that is enough to discuss for this part. I'll not go now go to the S factor that I wanted to discuss in previous class. That is the astrophysical S factor. Astrophysical S factor is nothing but the rescaling of a nuclear reaction. Nuclear reactions total cross section sigma I. Why we do that? We do that to account for the Coulomb repulsion between the charged particles. So, if you want to define the astrophysical S factor, then you can tell that it is nothing but a rescaling factor, rescaling term of the nuclear reactions cross section. That means we know that nucleus reaction cross section is sigma I. Then, if we rescale it somehow, what is that I'll tell. If we rescale it, then what we will get is astrophysical S factor. And why we need to define another factor just by rescaling it? Because when we rescale it, we consider the Coulomb repulsion of the particles in case of astrophysical S factor, which is not been considered in case of cross section. That is the cause why we are introducing another quantity. So and if someone tells that which one is more important, cross section is obviously important. Without the cross section you can't calculate the reaction rate and all those things, but astrophysical S factor is the more astronomical quantity kind of thing, people will tell you more about astrophysical S-factor rather than the cross section. Cross section is a nuclear physics term, but in case of astrophysical calculation or astrophysical study, we normally use the astrophysical S-factor. And if you want a definition, maybe I can write it. Definition is, it is a rescaling of a nuclear reactions total cross section, that is sigma e, to account for the Coulomb repulsion between the charged particles. And mathematically it is defined as S equal to E by e to the power minus 2 pi eta sigma e. And by this time you already been introduced with this astrophysical S-factor several times. There in week 4 content, there are a lot of times when we have used, the professor have used this astronomical S-factor. But I found that maybe a fundamental definition and fundamental understanding that why we are using this and what is the purpose of doing this and what is the definition of it, that will be helpful for you to remember the thing that why we are introducing it again, apart from another other quantities. So what are the parameters here? Where eta is Z1, Z2 is square by 4 pi epsilon 0 hv, which is called Sommerfeld parameter. I will not go into the details of these because these are already discussed in week 4 content. And sigma is cross section. E is energy. Z1, Z2 is square is product of charges of the reactants. And you all know that epsilon 0 is nothing but the permittivity of the free space. H bar is reduced Planck constant. You can write H bar is equal to H by 2 pi. So this is H bar, reduced Planck constant, and V is the relative incident velocity. So yes, this is what we call the astrophysical S-factor. I'm not writing about the epsilon 0, H, V, all these terms. These are very fundamental terms. We are all very much aware about this. So this is how we define it. Let me do a box here to highlight. Okay, all right. So that was the astrophysical S-factor. Now let me come to the cell model perspective again, that I have given you as a homework. That what is the ground? Let me heading as cell model revisit. As homework, I have given you to solve this 443 CA20, 13N7 and 11B5. Now what are the ground state of this, one by one? So first I would like to ask you everyone that anybody has solved this? Okay, first let me ask that everybody has understood the cell model. I have discussed about liquid drop model and cell model in quite elaborative manner in previous class. So did anybody get that what was the point of liquid drop model and cell model and how to calculate the ground state? If yes or no, let me know by chat or by unmuting yourself. Do you all have the notion of the cell model now? Come on, guys. Let me know that if you have already understood the cell model or not.
Ma'am, we can understand the shell model, ma'am. But while you're taking the class, it's very easy to understood. But after we recall the orbital and all, very difficult to work out, ma'am. So very difficult.
Yes, yes, yes.
Uh, the shell model, while you took the class, it's very easy. Afterwards, I recalled some of the orbitals, right? The J orbital. It, it's quite difficult to work out, ma'am.
Okay, so you are finding it difficult to get the ground state.
Yes, ma'am. Yes, ma'am.
So okay, so let me revisit it again from the previous class very fast. Okay.
Okay, ma'am. Yes, ma'am.
Okay, that will be helpful for everyone, I guess, and then I'll calculate these three, whatever I gave you in homework. Then it will be more helpful because you will cease to solve me again, and you will recall those things, and then again you will practice by yourself. Then you will be get able to solve it.
Okay, ma'am. Yes, ma'am.
Okay, so as per as he or she has discussed, I will go to the cell model again. So this was the cell model that I discussed in previous class, that first of all we were trying to model our nucleus, and we see that we can first we consider that maybe we can consider the nucleus as a liquid, as a liquid drop. And we know that liquid drop usually in the stable condition considered to be in a spherical structure. So if it is spherical like structure, then we discuss that we can study many properties and describe many properties of the nucleus by using the liquid drum model. But there was though that is a good model, but there were some problem. What was the problem? The problem was that the liquid drum model was unable to describe the stability of magic numbers. For that we needed another model which we call the cell model, and cell model is a model which is when we do the vector atom model in case of electrons in atom, it is comparable with that model. We are considering that electron in nucleus, neutron and proton are also distributed like a cell like manner like electron. Then what we get is called the cell model, and by this model we can describe the stability of the magic numbers. And what are the magic numbers? Magic numbers are 2, 8, 20, 50, 82, 126. Then we write the cell model, that how we write. We first get the 1 is half, 1 p 3 by 2, 1 p half. This by this way down to up we go by this manner, and we can see that this 1 is half is 2 is corresponding to 2, because why 2? Because this is a j, 2j plus one number of neutron or proton, that is a nuclei, are there in a particular cell. So 2 here j value is half, so that 2 into half plus 1, that is equal to 2. So here it is 2. So in case of here I have explicitly written that 1 is half. This half is this half is j value. This s, whoever have presented her screen, please stop her screen. Okay, all right. So I discussed that this half is the j, that is a j, and this is the l value, and one is the n. So it is like n l j. Yuvasri, please unmute yourself. Yes, okay, all right. So if s equal to z, s equal to s means if l equal to s, then it means 0. If l equal to p, that means 1. If l is equal to d, that means 2. L equal to f, that means 3. L equal to g, that means 4. These are the numbers of L, these are the L numbers. Now 2j plus what number of nuclei can be there in a particular cell? So if j is equal to half, then there can be two number of nuclei, neutron or proton. J is 3 by 2, then it is 4. J is 5 by 2, then it is 6. Sorry. If it is ground state calculation, if it is a even odd or odd even type nuclei, that is what we get mostly in the examination or question, then how to calculate the ground state? Then we took the example of 8O17, where proton number
Excuse
is,
me.
yes.
Can you please show the number of nucleons in each shell, your presentation? Yes, yes, yes. The
Okay.
D in the where 12 nucleons are there
Mm-hmm.
in this D 5 by 2. In
Yes.
that state, that 6 nucleons are there.
Mm-hmm. Yes.
How that 6 is there?
uh,
5 by 2, then that it should be according to that calculation. Okay,
two.
okay, 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 okay. Sorry, sorry. Yes, 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 yes.
All right.
Yes, I get it. Yes, yes,
Okay,
yes.
okay, good. Okay, if anybody have any doubt, please ask. Don't be shy. All right. So, 8017, we discussed about this example. P is proton number, that is 8. 8 is a even number, and N is 17 minus 8, that is a number of neutron, that is a odd number. Now, on the basis of what we will calculate the ground state? Now we can see that proton has eight number of protons there are in the nuclei, and there are nine number of neutron in the nucleus. So 9 is greater than 8, obviously. Those numbers, if neutrons are whichever is greater in number, either it is neutron or proton, we'll consider that only. Here neutron number is greater than the proton, so we'll consider the neutron, not the proton. Now once we know about the number of neutron, that is 9, and it is odd, then we'll and it is even odd configuration, then we'll write it in terms of the cell model configuration. How we'll write in terms of down to up format, and that is 1 is half 2, 1p 3 by 2 4, 1p half 2, 1d 5 by 2 1. Why we are writing it 1? Here it should be 6, right? But you can calculate that 4 plus 2, that is 6, plus 2 8, plus 1, that is 9. We have already reached to 9 nuclei, 9 nucleons. So as we have reached already to the 9 nucleons, so we will not go further. So there are two in here. First it will fulfill this ground, this state, then it will fulfill this state, then it will go to fulfill this state, as as per that time, when it is not reaching the final number of neutron or proton, whatever is there in the nucleus. As here it is 9 number of neutron, so it will go up to 9, and it is ending at 1d 5 by 2. And as it is 1d 5 by 2, so we can understand that 5 by 2 is the j value, and l is 2, and we have to calculate the gs like j to the power minus 1 or to the power l. J is the state, that is 5 by 2 minus 1 whole to the power L means minus 1 whole to the whole square. L is 2. That means it's plus 1. Plus 1, we only write it as plus. So 5 by 2 plus, that is the ground state for this 8017. This is the first example that I shown you for even odd nuclei. Even odd or odd even. Now the odd nuclei. For odd, I took the example of 7 and 14, where number of neutron is 7, number of proton is 7, and if I write in terms of cell model configuration, then I will get 1 is half 2, 1p 3 by 2 4, 1p half 1. Then 4 plus 2 is 6 and 1 is 7. So last is 1p half. And in case of neutron and proton, both will have the same configuration because both have the 7 7. In case of odd, if someone has the 7 and 9, for ordered nuclei, you have to calculate both for proton and neutron. Whereas for even odd case, you just need to calculate those who has the more number of thing. Either it is neutron or it is proton. But in case of odd, you have to remember you have to calculate for both neutron and proton. As this is 7 for neutron and proton both, so I am writing only one configuration because both have the same configuration as they have the 7 7 neutron and proton similar number. So total number of angular momentum, what will be that? That will be Jp plus Jn plus Lp plus Ln. For proton, J value; for neutron, J value; L value for proton, L value for neutron. Now, if you add them up and get if it is even, then Jp minus Jl. Then you have to calculate Jp minus Jl for total angular momentum. And if you calculate it as a odd number, then you have to calculate Jp plus Jn as a total angular momentum. This will be the final answer ultimately. This will be the final answer. But before that, you have to calculate that if I add all the angular momentum term, then if it is coming even or odd. If it is coming even, then it is minus. If it is odd, then it is plus. Then you have to calculate the plus or minus state. It will be plus or minus. For that, you have to just do minus 1 whole to the power Lp cross minus 1 whole to the power Ln. Here Lp is we have now the last state was 1p half 1. For that, I have written Jp is half, Jn is also half, Lp is p, that means 1, Ln is also 1, and total angular momentum Jp plus Jn plus Lp plus Ln, that is half plus 1 plus 1, that is 3, which is again an odd number. So odd number means I have to calculate Jp plus Jn. So now I will calculate Jp plus Jn, that is half plus half equal to 1. So finally what will be the plus or minus state? For that I have to calculate this. And for that I have written here minus 1 whole to the power 1 minus 1 whole to the power 1 because Lp was 1, Ln1 was 1. So minus 1 into minus 1, that is equal to plus. That is equal to plus. So the finally the state will be 1 plus state. And I told you that for even nucleus, for if you get an even nucleus, then the state will be always the ground state will be 0 plus for even case. Let me write it here. Even nucleus, it will be 0 plus state. So that is the summary of the cell model again. So you can it can describe the stability of matching numbers, and we have the model cell or the cell distribution, which is the most important thing to remember. To find out the ground state, you need to remember this cell structure such that you can calculate. Now for different cases, you have to follow different rules. Firstly I show you for even odd or odd even nucleus, that is, and second I have shown you for the ordered, and even is very easy, that is always 0 plus. So even odd or odd even, we have to follow few steps. And what are those are first you need to check what are the number of proton and neutron, whichever is greater, just write the cell model structure of that only. Then find the last stage where the electron is. According to that cell, you will be able to calculate the ground state. That is the GS. That is the GS, which is formulated as J to the power minus 1 whole to the power L. J is 5 by 2 here in case of 7 and 8 to 17, and plus is the state, ground state, that is minus or plus, that is plus here in case of this example. And how to and you need to remember this thing also, that what is the formula for this even odd case. For ordered case, you need to do for both neutron and proton. You have to write the cell structure, then you will be able to get the idea that at which cell level the neutron and proton are there. Then you have to calculate the total angular momentum on the basis of the last filled cell where the last nucleon is. Then you, if it is even, then you have to calculate jp minus jn. If it is odd, then you have to calculate jp plus jn. And for the plus or minus state, you have to calculate minus 1 whole divided lp cross minus 1 whole divided ln. Now if you calculate, now you know the plus or minus state, and you also know the total angular momentum. Now you can write it as a j total to the power minus 1 whole to the power lp cross minus 1 whole to the power ln. That is the formula you can consider here. And even 0 plus. So this was the cell model that I discussed in previous class, and again, as you told, as you tell now that you are finding problems, so I discuss again. But now let me do these problems one by one. Maybe then you will be, and you will tell me that what to do next. Then you will be totally clear, I think. And obviously take any nuclei, any nucleus you take, and try to find out the ground state. Then first try those which has already been discussed in this class, in this discussion session. Then if take any other which you know the answer or already given, or it is somewhere, then you try to calculate it by yourself, or you calculate it by yourself and discuss with me next class, or whatever you can find the way. You just practice yourself to get the idea that if you are getting right answer or not. Now let me calculate it for first question, that is 43 ca 20. Now you will tell me that what is the number of proton. You will guide me to solve this problem now, so that I can understand that you guys have got the idea that how to solve it. And obviously take the notes such that you can revisit it again and again. And there are again the YouTube channel where you can find again the discussion, and you can pause it there here and take the notes again by yourself, or solve it by stopping the video. This type of things you can do that there. But yes, now you tell that what is the number of proton here. Here the number of proton is
20, ma'am.
20. Yes. And number of neutron
23.
93. So what should I do now? This is which kind of nucleus?
Odd nucleus. Odd.
This is even odd, na? This is even. This is odd. Even odd nucleus.
Okay, even odd. Yes.
Yes, even odd nucleus. So what we need to do? We need to do the thing for even odd, and even odd formula was J1 minus 1 whole to the power whatever will be the L. So I will calculate it for, so for which neutron or proton, for which I need to write the cell structure now.
Proton.
Yes, it is for the neutron, because neutron has greater number of, there are greater number of neutron than the proton. So neutron, I will write the cell structure of the neutron, that is 1s half 2. You guys also try to write it by yourself. 1p 3 by 2 4, 1p half 2, 1d 5 by 2 6, 2s half 2, then 1d 3 by 2 4, then 1f 7 by 2 3, 4 5 6 7 8 9 10 16 17 18 19 20 23. All right, now we have reached.
I have a doubt, ma'am.
Yes.
Ma'am, how can I remember the series, ma'am? By mugging the series 1 by 2 the whole square.
Sorry.
That series, right? You wrote a series, right? 1s 1 by 2, 1p 3 by 2. These series where I can how can we remember, ma'am?
Okay.
By hotting it.
For that you need to one thing you need to remember actually, to find out this ground state, that is this structure. This this structure, this red box structure, you need to remember this.
Okay, ma'am.
Okay, you need to remember that one is half first. This is the first cell, then the second cell is 1p3 by 2, it is going down to up now. Then this is the third cell, this is the fourth cell, this is the fifth cell, this is the sixth cell, and up to 50 magic number I have given you the cell model, because up to this part, it is not very complicated, and up to this part you are going to, if you get any question from this cell model, then it will be within 50 magic number, not more than that.
Okay, ma'am. Okay, ma'am.
Okay,
Then
now
how
you
can we
need.
fill the electrons, ma'am? That two electron for s orbital, we can fill the two electron, right? Then p orbital,
Yes,
how can we fill the electron numbers, ma'am? In power.
here we are not talking about electrons, here we are talking about nucleus.
Oh, okay, ma'am. Okay, ma'am.
This is the study of nucleus, this is not the study of electron, but here I am telling, or in the cell model it is considering that, let us assume that nucleus also works as electrons. If that happens, then electrons have a cell model, and we can consider with the comparison of that electron that it also has a cell model which follows this kind of pattern what we get in case of need electron. Now if you tell about the number of particles, number, suppose if I am writing it for the proton, then there are two proton. If it is 4, then there are 4 protons, and proton neutron, these have multi if integer multiplication of the h bar by 2, so the h bar, so we will not have this spin up spin down case, here we will have the single entity. So and here it is for 1p half, again there are two neutron or proton. Then if you consider it for 1d 5 by 2, then there are 5, there are 6, and so on so forth. So this is how we are considering with the comparison of the electron that nucleons also be like this manner, and we can consider a cell structure or model for nucleus also.
Okay, ma'am. Okay, ma'am. Now I can understand.
Okay.
Thank you.
Okay, all right. So now I was calculating for the 43 CA20. So this is 1F 7 by 2 3, that is the last stage, last state of it. So J value is 7 by 2, L is equal to F, that is equal to SPDF, that is SP, S equal to 0, P is equal to 1, D is equal to 2, F is equal to 3. That means F is it is equal to 3. So minus 1 whole to the power L means minus 1 whole cube, that is equal to minus. So now J to the power minus 1 whole to the power L, that is equal to 7 by 2 minus, that will be the answer. Now I'll tell you guys to please solve it for the. Oh, I already have done for 13 and 7. Let me check what I have done. What I have done. What I have done. I have done for 7 and 14. Okay. Now you please do it. All right. All right. Okay. Now you guys please do it for 13 and 7. I'll wait for 5 minutes. I want the answer. What will be the ground state of it? Everybody please solve, try to solve at least. Maybe you will be wrong or right, that does not matter, but you should give a try.
Half minus 1.
Yes, absolutely correct. The answer will be half minus 1. Anybody else? Excellent. Very nice. Whoever is trying, please do.
Yes, ma'am. Half minus one.
Okay, great. Other people, please try. Give a try.
P by 2 minus 1.
Good. Very nice. Very nice. Okay. Anybody is trying, please try. I After one more minute, I'll move to the next problem. And still, if anybody finds any problem in calculating the cell model, then I'll solve again these two problem in at last of this class. And yes, please, if anytime you find that you need to listen this discussion or see this, go revisit the lecture again in the YouTube, or revisit this lecture notes. One more important thing, that is, many people has joined the Google Drive folder. They have shared the mail ID with me, and I have given the permission to see the lecture notes, whatever material I am giving, extra material I am giving, or whatever the slides are. And I think those with whom I have given shared this file, and they have the permission, they can see it. But whoever has not joined yet, please join it, so that you can get these materials anytime and check these things again and again. Those who have the permission, they can see it now. Anybody has checked? 3 by 2 plus. Okay, let me write it quickly. N equal to 6, P equal to 5, 1 is half 2, 1 P, 3 by 2, 3 is, it means 0, P means 1, that means 3 by 2 whole to the power minus 1 whole to the power 1, that means 3 by 2 minus. So answer will be 3 by 2 minus. Okay. Maybe you have done a slight mistake because S means 0. Remember that S means L equal to 0 and P means L equal to 1. So it will be 3 by 2 minus. Maybe you have done a little mistake. It does not matter. You are trying and it is very good that you are getting the answer. But yes, try a bit more. Practice a bit more so that you can't. It is always right.
Okay, ma'am.
Okay, so now I have to discuss many things. I will discuss quantum tunneling today for sure. Because I am telling about this thing for quite a long time, and this is the right time to discuss about it a bit. Not, I will not solve it totally because if I solve it the total problem, then it will take itself 3 hours. So I'll develop the idea and I'll develop the equations, and but I will not solve explicitly, but I will try to generate the idea what is the quantum tunneling. But before that, let me know that I think many people here are also familiar with this quantum tunneling concept. But anybody has actually mailed or write it in the Ask a portal, that that's why I need to discuss about this. But are you guys familiar with this quantum tunneling? Anybody? Write into chat or unmute yourself and tell. Or do you know about rectangular potential barrier? Solution of this quantum mechanically. Okay, I think I should start.
Yes, yes.
Okay, so I think I should start, and I will not spend much time because I need to solve many questions today. So I have not started one yet till now. So the first thing is that first question which should be arise, if you don't know about quantum tunneling, then why you are talking about quantum in astrophysics? First question, because we are talking about nuclears and nuclear astrophysics, so it is all we are talking about the nucleus things, and by now liquid drum model, cell model, many things we have done. And if it is nucleus and atomic level, thought about atomic level and nuclear level, then obviously there will be quantum mechanical behavior. And this nuclear fusion, fission, all this happens due to some not due to some classical events, but this is totally quantum mechanical behavior that we get. And the generation of the alpha particles and all those that have to cross the Coulomb barrier, all those concepts are coming from the quantum tunneling concept. And the basic problem to get the idea of quantum tunneling is the rectangular potential barrier, and solving this rectangular potential barrier with the help of Schrodinger equation. We know the basic equation of quantum mechanics is Schrodinger equation, and that is let me write the Schrodinger equation first. H bar square by twice m del 2 d2 psi dx2 plus v psi equal to e psi. This is or we can write it as h psi is equal to e psi, where h is the Hamiltonian, e is the energy. So if you write in the some operator terms like bracket notation, then it is equal to e psi. Psi is the state vector here. This is a state vector. and H is the Hamiltonian operator. If we operate Hamiltonian on a state vector, then we get some eigenvalue, and this eigenvalue in case of Hamiltonian is the energy. So this is nothing but the conservation of energy. Very basic concept, but we can show it in quantum mechanical behavior, and it gives us lots of facts, lots of discussion, lot of understanding, helping using this Schrodinger equation. And those who are in BSc or completed BSc or masters or BTech final year, maybe whatever, they are pretty much aware about this quantum mechanical nature and Schrodinger equation at least. So what is the rectangular potential barrier? Rectangular potential barrier, always we talk about some potential, like because we have some h bar squared by twice m d2 psi dx2. This is the kinetic energy part, this is the potential energy part v psi, and this is the outcome of that. Then this is the concept, as it is a conservation of energy, then v is the potential. That is what, yeah, with the variation of this potential we can get different barrier. Like if v is like, we already know about this thing, because we know about the Coulomb potential, we know about any kind of classical potential, if it is potential energy or whatever. So whatever the for the presence of any body or anything has some potential energy, and this potential energy, if it is a specific type of potential energy, that is called rectangular potential barrier, such that Vx, that is the V, is equal to 0 for suppose x less than 0, V 0 for 0 to a, and 0 for x greater than a. Then this kind of potential give a visualization or understanding of rectangular potential barrier. How? If I draw this, then it becomes like this. X is going in this direction, x equal to 0, x equal to a. This is the region 1, region 2, region 3. Vx equal to 0, Vx equal to at this point, but here this barrier, this is creating the barrier, that is the extra potential. This is the 0 level, this is the 0 level. Extra part is there in between 0 to a, that is v0, that is creating another barrier. Okay, so this is just like this. Now so we can consider this is kind of a rectangular thing, right? That's why you call it a rectangular potential barrier, nothing more than that, nothing more than that. Then we can write, then we can consider it now in case of classical thing. Suppose we have a wall is also like this. This is the ground level, and this is the wall. Wall is nothing but a certain barrier. Suppose it is v0. Classically, now a ball, it is coming. Previously we also used to consider photon as a particle, right? For even we can't say it is not a particle, it has a dual behavior. Photon has a dual nature of being a particle and wave like behavior at the same time. But now let me consider it in case of classical wave. This is a wall, this is a barrier of v0, and a particle or ball is coming. Then what it will happen? It will reflect, either is this or that direction. It will always, there will be some reflection, there will be no transmission. There is no such way that it can go beyond just इसको छेद करके इधर निकल गया, ऐसा नहीं हो सकता है. It is never possible that it will go from the wall and go to the other side of the wall. It is never possible. Either the wall has to be broken, otherwise it is not possible. But we are not considering here in case of anything breaking thing. So if ball is coming and it is guided by any barrier, then it will obviously get reflected. So total energy, if you tell in terms of reflection and transmission energy, then that is r plus t. R means reflection term, and the transmission term. So the total thing is always one, because it is always conserved. It never can be destroyed or generated. So if it is 1, then in case of classical case, then r is equal to 1, t equal to 0. That is what gives you 1. Always only reflection, no transmission. But the peculiarity arises when you consider in case of quantum mechanical case. What happens? There is this potential barrier. A photon is coming. We don't know if it has a dual nature. Sorry, let me draw it a better way. It is coming, but it will not only reflect, it will also transmit. It is never it is never possible to describe by a classical understanding or classical feature or classical property. It is a purely quantum mechanical behavior, and that is what is peculiar. That is why we are able to see nuclear fusion. That is why the 4H or the alpha particle generates even. Because if a gamma, like whatever I was talking about the photodisintegration, gamma is coming, that is a photon is coming, and it is falling on the Fe nucleus, and it is generating many 4He or neutron, proton, all those things. If it is a classical like ball, then two are coming, then it will always obviously reflect, because it is a barrier, it will never cross it. But due to the tunneling perspective, due to this quantum mechanical behavior, only this fusion happens and it breaks into the smaller parts. Okay, so that's what the concept of rectangular potential barrier or the quantum mechanical tunneling. So yeah, if you want some mathematical background, then I can solve it. I can write the three Schrodinger equations, how it will look like in case of region 1, region 2, and region 3. Here it is region 1, region 2, and region 3, and that will be if you calculate. I have already written it, because otherwise it will take much time. If you calculate it, then you will get like this: d2 psi dx2 plus 2me by h bar square psi equal to 0, where d2 psi dx2 is plus p square p1 square by h bar square psi equal to 0. P1 is equal to root over of 2me. Region 2, it will be d2 psi dx2 plus p2 square by h bar square psi 2 equal to 0. P2 equal to root over 2me e minus v0. Now this is important. I need to write it explicitly, that how I got this. The basic equation is h bar square by twice m d2 psi dx2 plus plus v psi equal to e psi. E psi minus e psi plus e psi. Okay. All right. So now this potential is now V0 in case of region 2, that I have already shown you. This is V0. This is V0. So once we have V0, then you can then you can write it as h bar square by twice m d2 psi dx2 plus V0 psi equal to e psi. If you rearrange it and write it, then you will get h bar square by twice m d2 psi dx2 plus 2m, sorry, plus e minus v0 psi equal to 0. And finally you get this d2 psi dx2 plus 2m e minus v0 by h bar square psi equal to 0. And that is why I have written p2 is equal to 2m e minus v0 to the wholes to the power half. That is equal to, if we can write it the Schrodinger equation like this. This is for the region 2, and finally the region 3. Region 3 will be again the same like region 1, and it can be written directly as d2 psi dx2 plus p1 square by h bar square psi equal to 0. Why I am writing again p1? Because that will be also root over of 2me. You can check it by yourself. Why it is already 2me happened, because here d2 psi dx2, let me write the first step also, plus v psi equal to e psi. V was 0 for region 1 as well as region 3. So only this 2me by h bar square psi term was there, and I got this final equation. So we can write the Schrodinger equation for all the three things, and we can maybe denote it with different psi 1, psi 2 and psi 3. And let me box these three. This is 1, this is 2, and this is 3. So we have these three equations. Now we need, if we solve them, then what we will get is psi 1 equal to a1 e to the power I p1 x by h bar plus b1 e to the power minus I p1 h bar x. Psi 2 will be this is just, now what kind of equation is this? This is just simple harmonic oscillator kind of thing, what we write in case of like d2 d2x dt2 plus kx equal to 0. This kind of equation this is. Thus we can directly write these terms whatever it is getting, or maybe you can also solve the ordinary differential equation. You will get this. So psi 2 equal to a2 to the power what happened? Okay, I p2 x by h bar plus b2 to the power minus I p2 x by h bar, and psi 3 will be a3 to the power I p1 x h bar plus b3 to the power minus I p1 h bar x. Now there will be no term like this, because there is no possibility of going backward in case of region 3. There is no possibility of going backward in region 3. That's thus this part is 0. This is the incident wave, this is the transmitting wave, then again it is the incident, it is the reflected, this is a transmitted part, it is again the reflected part from the region 2. So this is all about the reflection and transmission. What we get in case of classical, there is no transmission, but in case of quantum mechanics, we get the transmission. So finally we need to now always there need to be the property that should be hold, is that it is continuous, the function is continuous, that is wave function is continuous over all the area. There will be no discontinuity. For that, what we need to follow is psi 1 equal to psi 2 at x equal to 0, which is the wall 1 of the barrier, and psi 2 is equal to psi 3 at x equal to a, which is the wall 2 of the barrier. At this point, these two conditions should be satisfied. Apart from that, for the discontinuity and continuity purpose, we know that we need to also to confirm that if something is discontinuity, something has any discontinuity or not, we need to we need to get the differentiation of that also, and that should also be continuous in that area. That is d psi 1 dx equal to d psi 2 dx at x equal to 0, and d psi 1 d psi 2 dx 2 dx equal to d psi 3 dx at x equal to a. If you put these four conditions and solve these three Schrodinger equations, three equations that we get from here, then what you will get is a solution, and that is a 3-page solution. So I'll not do that. Three, not even 3 page, 1 page, 2 page, 3 page, 4 page, 5 page, 5 page solution. So I'll not do that. So what will be the understanding of it? It will be the understanding that if the total energy is equal to reflectance plus transmittance, then in case of classical it was only reflectance, but there will be some reflectance and some transmittance. So it will not only reflect from the barrier, from a solid barrier, but it will break the barrier, or it will grow from the barrier and go to the other direction. That means it will have the reflectance and transmittance. That is what is called the tunneling, quantum tunneling. And we can finally draw this, that there will be this is the barrier v0, this is zero level, ground zero level, then it is coming like this, and now it is going like some attenuation, and there will be some difference in the amplitude, obviously, because some part will always be reflected, that is reflectance term plus transmittance term, but some part will be transmitted. So that is why we get the quantum tunneling. So that was a discussion of quantum tunneling. It was pending for a longer time. I wanted to discuss this, and people wanted that students wanted to discuss it bit once, so that there is no confusion with the quantum mechanics and quantum tunneling. So I discussed this, and why are using quantum tunneling, because for this alpha particle transmission, photodisintegration, all those things are happening just because of the quantum mechanical tunneling. Otherwise this nuclear fusion thing will not be happening. So that is a fundamental, absolute fundamental understanding of the quantum tunneling, why these fusion things are happening. Okay, so let's not discuss any more thing about this, and I'll now go to the question answering thing. What is the main purpose of this problem solving session? But today I have taken the problems from your assignment 4, because those were heavy problems and you need to understand all those. But before that, let me write the equations. No, maybe not write the equations, I will directly solve the questions, and with that you will get the idea that which are the main equations that we need to solve this kind of problems. All right, 16, 17, 18, 19, 20. All right, so the assignment 4, question 1. Question 1 is telling at stellar temperature T6 equal to 15. These are all given in the given keV temperature scale. The effective, such that you don't need to put again the keV those things again. 15 means 15. You don't need to change any scaling here. The effective burning energy, that is a Gamow peak for P plus P reaction, that is a PP reaction, is what? Did anybody solve this during your assignment? When you solved your assignment 4 for the coursework which you have submitted already, anybody solved it? Because it was there in the assignment 4. As I am not getting any response, so I assume that maybe you are not very comfortable with this. So what we need to calculate is just the effective mean energy E0. That is all. That is the thing that we whatever we need to calculate here, and formula is 1.22 Z1 square Z2 square mu T6 square whole to the power 1/3 keV in keV range. Now, if you ask me that how I get this formula, then obviously and then I would answer that it was discussed in your lectures, week 4 lectures. Okay, so the effective main energy, this formula has been already discussed with you, so that I am writing this formula directly without deriving it. But you need to remember it for your final examination, or your for your final examination, or your uh, uh, learning purpose. So the effective energy is 1.22 Z1 square Z2 square mu T6 square. 1.22 is the Z1 Z2, you know the reactants proton number, or the, and then the mu is a reduced mass M1 M2 by M1 plus M2. T6 is the temperature. Then how will we calculate 1.22 mu 15 square, because others are 1, Z1 is 1 in case of proton. Okay, in case of proton, so Z1 is 1, Z2 is 1, mu is need to be calculated, and 15 square is the T6 is 15 is given 1/3 keV. Now mu is equal to M1 M2 by M1 plus M2, that is equal to 1 cross 1 by 1 plus 1 equal to 0.5. So E0 is equal to 1.22, 0.5 into 15 square to the power 1/3 keV, that is equal to 5.9 keV. Now I'll box this formula, because you need to remember this formula to solve question like this. Alright, so this was the first question, that what is the effective burning energy at gamma peak for PP reaction, and answer was for there are 6 options here, and the answer is 5.9 kilo electron volt, that is the option C. Now I'll go to the question 2. Please again and again solve these questions and remember this formula, otherwise it will not be very helpful. And anytime you find any difficulty, please let me know, let others know, and discuss with your friends, write in a ask in a question portal, or write comment it in my YouTube video, or write directly to me via mail, or you can also go write in the chat box, even in even tell by unmuting yourself. So the next question is this reaction, the dp gamma 3ag. I hope this kind of notation is also familiar with you by now, because it was already discussed by professor in week 2, that why just by writing this dp gamma 3ag, you will be able to understand that what is the reaction. This is the target, this is the projectile with which you are targeting is your target, and this is what it is coming out of it, and this is the product that you are getting from the reaction. That means D plus P gamma plus 3ag, sorry, 3ag, or you can write also like this D, it is coming like proton, and it is going like gamma and 3h. So this was just a short note again to remember, to such that you can remember these things again and again, and I will try to revise all those things again and again, such that you don't miss anything from previous classes. So question 2 is telling that this reaction has the Q value 5.493 MeV, has been measured at center of mass. Energies above ECM is center of mass, equal to 10 kilo electron volt. The Coulomb barrier for the DP reaction is what? So you need to calculate the Coulomb barrier. for this reaction, and R0 is given 1.2 angstrom. Sorry, I have not written in LaTeX here. For that you need you can see that R0 is just R and 0 written one by one. I'm sorry for that. But this is R0, that is that I have already discussed. R equal to R0 to the power one third. That is how the radius of the that is how the mm, uh, that is how we calculate it. All right. And somebody is asking why it is 1 1, because we consider that z for proton, we that is only one z, that is z equal to 1. And if proton is z equal to 1, then only we have 1 plus 1 by 1 plus 1. It has 2 z PP reaction, that means 2 proton, Z1 is equal to 1, Z2 is equal to 1, and M1 is only considered just because of the Z1 Z value. So M1 is also 1 plus 1 by 1 plus 1, and that is equal to 0.5. Now if you want here it is already is given in the proper in this formula. It is already the unit changing is not necessary. Whatever is given, it is in AMU, and all those necessary all those unit changing thing you don't need to do. Just write 1 plus 1 by 1 plus 1, that is the z value. That is what is actually mass of this, and that is what you get as m1 m2, and you can calculate the reduced mass as m1 m2 by m1 plus m2, and that is why it is getting as 0.5. So now next is Coulomb barrier. Coulomb barrier, there is again another formula that is already been discussed in your class. Z1 Z2 by E square into R by R. And I will again box it. You need to remember it. And I don't think you need to remember it, because you are doing it from class 12 level, class 2 level. Excuse me. So now for this reaction, Z1 is again 1, Z2 is 1. E square directly can be written in terms of keV as 1.44 and the minus 10 10. All right. All right, kilo electron volt into centimeter. I'll write the unit at the end. Maybe Z1 Z2 is square, and R equal to R0 to the power one third. R0 is given as 1.2 angstrom, that is equal to 1.2 into 10 to the power minus 8 meter, 10 to the power minus, sorry, we are going to do in centimeter, so 10 to the power minus 10 centimeter. Now R is equal to, can be written for the proton plus neutron as R0 a 1 or a1 not proton per neutrino plus gamma, that is a1 whole to the power one third plus a2 whole to the power one third. Now I am going pretty fast because there are lots of questions to solve. If anybody find any problem anywhere, please tell me or write in the chat box, or please go to the YouTube video again to find what I have done and why I have done, to understand by yourself. Okay, so R equal to R0, these things. So EC can be written as Z1 Z2 E square by R, that is equal to 1 plus 1 cross 1.44 and then minus 10 keV centimeter by 1.2 into 10 to the minus 13. Sorry, I have written something wrong. 1.2 angstrom, it will not be correct thing, it will be 1.2 femtometer, and that is equal to that is equal to 1.2 and minus 13 centimeter. So 1 to the power one third plus 2 to the power one third centimeter cross. So now it will be only kV, and if you calculate it, then you will get this. And someone was asking about that Z1 Z2. I have already answered it in between. I hope it is clear to you for the question one about the M1 M2. I hope it is clear for you. And then I was solving for the Coulomb barrier, that is nothing but Z1 Z2 square by R. So one thing you find that if you remember the formula, you can solve it, but you need to be very careful about Z1 Z2 M1 M2 E value, R value, change in the change in the units and all those things. That's why I have discussed in the week 2 or week 3, week 2, I think week 2 or week 1, I forgot. I discussed elaboratively about the unit changes, because that is very necessary for solving this question. Otherwise you will get wrong answer. All right, so for that, what you need to do is that I am solving these questions. You have already tried to solve this question for your assignment 4. Now you need to check that if your thought were right or not. Check that if that thought were right, then what you have considered and what should be considered, then how you have done the mistake, and if you find the mistake, then correct it by yourself and practice it. Definitely you will get that how to do this kind of problem, and these are very simple question, but calculation is a bit hectic. Now question 3 is telling about, sorry, my um, voice is not so well, and health is also not so well sometimes. So yeah, let's go to the question 3. Gamow peak E0 of the dp gamma 3he reaction is at what? Gamow peak is also described to you. Let me tell, Gamow peak is also described to you, but let me write the. But there was not any particular definition that was given to you in the lecture. So let me write the definition of the Gamow peak. I am writing this because if anybody has misunderstood it, or if anybody has overlooked it, or not understood it, or just did not get it, then from this you will be clear. But you need to understand this, because there are a lot of time the Gamow peak will come in the due course, and you have already seen that in a week 4 later half course, later half lectures, there are a lots of discussion about the Gamow peak and all those Gamow factor, all those. So Gamow peak is can be described as narrow energy range over which most nuclear reactions occur in a stellar plasma. Narrow energy range over which the most nuclear reactions occur in a stellar plasma. That is what we call Gamow peak by physically. Physically, you need to understand it. And how we get this? The effective energy, effective mean energy, it follows Maxwell Boltzmann, and if you calculate the centroid of this Gamow peak, it is like this. And if you find the centroid of this Gamow peak, then you will get the effective energy. So here it is talking about calculating E0. E0 is nothing but the effective mean energy. That is equal to, again the formula is 1 minute. Yes, the formula is 1.22 Z1 square Z2 square mu T6 square KeV. That is equal to 1.22, again 1 square mu 15 square whole to the power 1/3 keV. If it is such, then mu is equal to here m1 plus m1 m2 by m1 plus m2, 2 cross 1. By now you should understand about these things, m1 m2 z1 and z2. If anybody is not getting, then please try to do it by yourself. Try to understand it by yourself, that how to calculate Z1, M1, M2, Z1, Z2, all those things, and try to find out this reduced mass by yourself. It will be helpful. So now here mu is 0.667, then E0 is equal to 1.22, 0.667 into 15 square whole to the power 1/3 keV, that is equal to 6.687 keV. Answer is this, and 6.48, that is nearly equal to 6.5 keV. That is answer A. That is answer A, and beforehand it was answer C. Again, the same type of problem. Question 1 and question 3 are same problem. And now it is about question 4. I'm sorry, I'm going pretty fast because lot of questions are there, and you guys have already tried these questions once by yourself, as it was there in the question assignment 4. So I'm going fast, but if anybody found any problem, let me know, let us know, anywhere, any place. I am asking you guys this for several times. Now, width of the Gamow peak. Width of the Gamow peak you need to calculate here. Width of the Gamow peak for this reaction is what? You need to calculate that. Now this again has formula, that is 0.749. You just don't need to do anything. These are all formula based question. Just remember the formula, understand what are the terms that you need to substitute, and what are the exact value of that. You will be easily able to calculate these things. Z1 square, Z2 square, mu T6 to the power 5 all to the power 16. Again I will box it. This is the question, this is the formula. Then if you substitute 0.749, Z1 is 1 square, 1 square, because this is again the P gamma, dP gamma, so that's why it is 1 square, 1 square. And if deuteron, let me clear again, D is 2 D1, that means 1 proton, Z1 is 1 proton number is Z1, that is why it is 1, and P is proton is 1, that's why it is 1 square, 1 square. Mu is again here, it will be 0.667 because deuterium has 2, M1 is, now it is M1, that means 1 plus 1, that is 2, that is the upper thing, 2D1, 2 thing, 2D1. So it is 2 cross 1 by 2 plus 1, that is equal to 0.667. Okay, so that's why it is 0.667 into 10 to the power 6, that is 15 to the power 6, that is to the power 16. In the unit of keV, you will get 6.687 keV. That is 6.687, that is equivalent to B. This is another formula that you need to remember. Width of the Gamow peak. Now the next thing is question 5. Question 5 is telling for dP gamma 3He reaction, T6 is 15 already given, the maximum value of integrand appearing in sigma V, Imax, that you need to calculate Imax. And Imax also you have been introduced in this course, and it was discussed there. Let me find that in which lecture it was there. I equal to Imax. Let me see, check it. Uh, which one lecture it was there? Anybody? Okay. In lecture 18, it was elaboratively discussed about how you got the IMAX, and IMAX is equal to yes, it was discussed in lecture 18 that how to, if the Gaussian function is there in the Gamow peak, then you will get the function, and what will be the IMAX you will also get. Please visit the lecture 18 of this nuclear astrophysics. You will be able to see the Imax, and it is equal to e to the power minus tau, where tau is equal to 42.46 z1 square z2 square mu by t6 whole to the power one third. You need to remember again this. I'll box it again. By now, by this time, I hope everybody is familiar with this z1 z2 mu t6 term. So I am not writing these explicitly again and again that what these terms are. You just remember this formula. So if it is like this, then we can calculate tau to be 42.2 sorry 46 1 square 0.667. Again the same reaction, so the same reaction, so the same z1 z2 value, and then t6 equal to 15 whole to the power one third is equal to 2.93 into 10 to the power minus 7. Okay, so this will be the answer. The this sorry e to the power minus tau will be this, and that is equal to I max. That is what you need to calculate here. And question 6, 7, 8, 9, 10. There are many questions. Before that, before going to that part, let me ask you guys that, are you guys getting these problems, or I need to go a bit slower? Because if you are not getting, then it is meaningless to go further. So I hope everybody is getting, because obviously everybody has solved this in case of their assignment 4, uh, so that I am going faster. But please anybody tell that, are you getting the points whatever I am saying?
Yes, ma'am. It's clear.
All right, that's great, very nice. So okay, all right. So now I'll go to question 6. Question 6, it is talking about the reaction cross section for the same reaction which was given to you at energy 0 equal to 6.5 keV. That is the maximum energy, that is the energy that we have calculated some time ago. Now it is given, and T is also given. S factor is astrophysical S factor is also given. Now they are asking what is the sigma e, that is a reaction cross section. Now let me write it down the values, otherwise it is not very clear from these slides. 6.5 kV, because I have not used latex here, I am extremely sorry for that. T equal to 15 megakelvin, AC equal to 0.20 into 10 to the power minus 6, uh, plus 5.60 into 10 minus 6 e plus 3.10 minus 6 e square MEVB. So now you need to calculate sigma E is equal to what? That is a reaction cross section. Sigma E is equal to 1 by e to the power minus 2 pi eta AC. I have all sorry I have also I have discussed this formula when I was discussing about the astrophysical S factor, but this has been also discussed in elaborative manner in your lecture also. So I will not discuss that how this equation is coming. Thus I'll move forward with the equation, and I hope this equation is well known to you by now. And this equation was given in lecture 17 or 18, lecture 17. Lecture 17, please revisit it if you forgot it. But this was the thing that the formula was given there, and you need to remember the formula, where sigma is a cross section, 1 by E is the energy, 1 e to the power minus 2 pi sigma, 2 pi eta, that is the Sommerfeld factor parameter. AC is the astrophysical S parameter, and eta is the e to the power minus 2 pi eta is the Sommerfeld parameter, and e to the power minus 2 pi eta is the Gamow factor. Sorry. So this is how the formula is defined, and I hope I don't need to write it. Maybe I can write Sommerfeld astrophysical S factor. This is the Gamow factor, this is energy. Okay. So the question is to calculate the sigma E. To calculate the sigma E, I will first calculate the 2 pi eta terms, that is 31.29 Z1 Z2 root over of mu is in AMU and E is in KEV. Then this is another thing that you need to remember. If you transfer it in AMU and KEV, what will be the net, what it will look like. Maybe I can also write it in terms of box it. Then 2 pi eta is equal to 31.29 into 1 into 1 into 0.667 by 6.5. These are in AMU and KV, so you will get 10.023. Now you need to calculate the AC. AC is equal to 0.20 into 10 to the power minus 6 plus 5.60 into 10 to the power minus 6e plus 3.10 into 10 to the power minus 6 e square MEVB. So if you calculate for A is equal to E is 0.0065 MeV, because it was given as KeV. Now I am writing at in terms of MeV, because naturally when we put it, it is in terms of MeV. The formula is written in such a manner. So I am putting it in terms of MeV, and if I put this E here, then what I will get is 2.365 into 10 to the power minus 7 MEVB, and sigma E is equal to 1 by E to the power minus 2 pi eta is E. So that is equal to 0.0065 MeV to the power minus 10.023 into 2.365 into 10 to the power minus 7 in MEV. That will be equal to 1.614 into 10 to the power minus 9 B. MEV will cut, and this is only in B, that is 1.614 into 10 to the power minus 6 milliborn now. Alright. So this is the sixth question. This type of question we can get. Now question 7. Question 7, another big problem. Question 8, another big problem. But maybe yes, only 10 minutes left. I don't know how much I will be able to cover up. Question 7. Question 7 is telling what is thermonuclear reaction rate per particle pair of the DP gamma 3He reaction. Same reaction. Now you have to calculate the reaction rate. So reaction rate means you need to calculate sigma V is equal to what? For that we need to calculate. Let me write the formula again. 1 by kt to the, these are all formula based question, but solving is rigorous. Imax, I'm directly writing it in terms of Gamow width and maximum energy, that is Imax. So that you need to remember this formula again. Reaction cross section reaction rate in terms of Imax and delta. Once you get this, then you know KT equal to 1.3 keV for this reaction. This P gamma that is given in your lecture again. Please watch these lectures very carefully to solve these assignments also. And yes, I agree that these discussion sessions are a bit slower than the assignments that you submit, but I talked with them as per as previous days discussion, but nothing can be done now. This will go in this manner only. So KT is 1.3 kiloelectron volt, mu is equal to 0.667, again Imax equal to 2.93 into 10 to the power minus 7, delta is equal to 6.7 keV, then S equal to 0.0065 MeV is equal to 2.365 into 10 to the power minus 7 MeVB. Sigma V is equal to, if you substitute all those terms, then it will be look like very horrible thing. 6.667 into 932.5 MeV whole to the power half 3, sorry, 3 into 10 to the power 10 centimeter per second, 1.3 into 10 to the power minus 3 MeV whole to the power 3 by 2, 2.365 into 10 to the power minus 7 MeVB into 2.93 into 10 to the power minus 7 into 0.0067 MeV equal to 19.013 into 10 to the power minus 3 BCM, but 19.013 MV centimeter second. That is what is the answer, and that is equal to answer C. Now the question 8. The question 8 is talking about the percentage change in the reaction rate of the same reaction at a stellar temperature of T equal to 20 megakelvin. That means you need to compare now. You have the idea, if you have the idea of one temperature, and there is one relation also. The relation, the percentage you need to calculate, but for that it was given something like this, like, let me write the formula. Okay, you have the formula sigma v, whatever was discussed in the lecture 18, that is proportional to tau square e to the power minus tau. If you can write it in terms of t, that is tau minus 2 by 3, because we are talking about percentage change in the reaction rate, which is this sigma v. Then it can be written as t to the power n, where n is equal to tau minus 2 by 3. So you need to calculate n also. You need to calculate to know the tau. If you know the tau, then you will be able to know the sigma v, and eventually you will be able to calculate the percentage. But this is a bit let me go to this problem and solve this problem, but after that also will be left with another problem. Maybe we will solve that last two problem in these two problem in the next class. So for today I'll solve this question 8 now. So the sigma vt, the relation is like this, and let me box it also, box this thing also. So what you need to do is sorry, again, sigma v t, sigma v t0, that is equal to t by t0 whole to the power n. Now sigma v at t by sigma v t0, I have already solved these questions, and the solution I have with me, that's why I am doing so fast, otherwise it will take lot more time. Is equal to t by t0 1. Now sigma Vt minus sigma V T0 by sigma V T0 into 100%. That is what we want to calculate. Now T by T0 to the power n, as we want to calculate the percentage. This thing is basic, and I hope everybody is clear with that. And now I need to calculate tau to know the n. Tau is equal to 42.46 z1 square z2 square mu by t6 whole to the power 1/3, that I have already discussed, already told you. For pp reaction, this one is pp reaction, z1 is equal to 1, z2 is equal to 1, mu is equal to, I mean dp, for dp reaction also d has 1 z2, that's why z1 equal to 1, it is considered as pp reaction only. So z1 is equal, mu is equal to 0.667, t6 equal to 15, tau will be calculated at 15.043, n equal to tau minus 2 by 3, that is equal to 4.348. Now the percentage will be t by t0 whole to the power n minus 1 into 100%, that is equal to 20 by 15 whole to the power 4.348. Why 20 by 15? Because we have already known for the 15, 15 is the standard thing with respect to which we are calculating for the 20 millikelvin, mega Kelvin, and that's why it is right this. Whenever you will find something percentage question, you have to write in terms of, or we have even done this for sigma with respect to sigma t0, right? T0 is 15 mega Kelvin, that's why it is 15, and sorry. So this will be like this, and you try to solve this kind of question with some other t6 other than the 20, like 30, 40, what will be the percentage, then you will get the idea that how to solve this kind of question again and again. So it will be 249.7%, and the answer is pretty odd, and but the answer will be like this. So this is the this was your question 8, and these all these questions are pretty numeric based question and involved question. You need to, I am again and again telling, you need to be very cautious about the unit changing, and these are question 1 2 3 4 5 6 7 8, and 9 and 10, those are the similar kind of questions. They are also, you need to calculate the n. Maybe I can take 5 minutes and go to that question also. Question 9, I'll do. Question 10 is homework for you, because question 9 and 10 are the same question. Take a snapshot of question 10, and you will solve that. And I start that. I start the next class from that by asking this question, that if you have understood the question 10 or not. Question 9, it is telling that the temperature dependence of Na is the Avogadro, that is the sigma V near some energy t equal to T0 can be given by introducing a power law. Na sigma V at T is equal to like this. The value of N for the P plus P reaction, that is PP reaction at T equal to 15 megakelvin, is what? That means we need to calculate the value of n. N is equal to tau minus 2 by 3. Now for that we need to calculate tau. What is tau? Tau is equal to 42.46 z1 square z2 square mu by t6 whole to the power 1/3. So for this tau will be 13.7 you can find out, and n will be 3.9. So answer is D. But yes, I did this very first, so I'll again cover up these two questions in next class. But question 10, please take the snapshot, and that is your homework. Try on the basis of question 9 whatever I have done right now. Just but I did not show you that in details calculation whatever is there. You please try to do it by yourself and find out the answer for the question 10 also. Question 10 is just the same of question 9, just the value is not t value is changed. Apart from 15 megakelvin, it is 200 megakelvin. Oh, okay. So these are the questions that I want to solve and I want to discuss with you. I wanted to discuss with you because these are pretty much involved question, and you got it in the assignment 4, and you can uh, get this type of question in your final examination. And I hope these things are clear to you. But if anything is not clear, please, I am saying again and again that please ask us, any one of us. And yes,
Ma'am, excuse me, ma'am. I
yes,
have a doubt, ma'am.
yes, please.
In finding of boron 511, that question, ma'am, ground state question,
Sorry, the
ma'am.
ground state.
Yes, ma'am. Ground state question for 5 boron 11.
Yes.
In that, you told me to take a highest value, right? For proton is 5 and neutron is 6. Then we have to take the value of 6, right, ma'am? Then how will it be the 3 by 2 minus is my doubt, ma'am, because my answer is 3 by 2 plus. I can't understand clearly, ma'am. Can you please explain?
So maybe I tell anything wrong, I don't know, but 1 minute I need to check. That is one is maybe let me check it. 1 minute.
Okay, ma'am.
What was the question? Question was 5B11, and this was 7 and 13. That is 7 and 7 plus 8. That's for the total 5, 6, 7, 6. Okay, all right. So one thing is that n equal to 6 and p equal to 5, right? I told the greater value you need to take, but greater odd value you need to take. And there is
Okay.
6 and 5. Uh, if the whatever is odd value, first you need to consider that. If
Okay.
1 minute, let me clear if I mentioned that anywhere else. Okay, see, in case of 20 calcium 43, proton is 20, n is 23. Though it is neutron number is greater, plus it is odd value. First you need to check if it is odd or not. Second you need to check it is greater or not. If it is odd, then it is already done. And then if it is not if it is if it is odd, then it is already not done, and then you need to check the which number is greater or not. But let me be clear with one more thing, that p equal to 5 and 6. One is half 1p 3 by 2, 1p 3 by 2, 1p 3 by 2, 5 2 3 4. If it is 6 also, if it is 6 also, that means 4, 1p 3 by 2. Lifetime, that is for the age. Okay, 5 বড় না? No, the thing is, 1 is half 2, 1p 3 by 2 4. There can be 4 nucleon in that state, right? N equal to 6 for neutron, we'll also only we'll consider for n equal to 6 because that is greater number. There is nothing like odd even. And 3 by 2 is for J, and minus 1 whole to the power L for P is equal to 1. That is 3 by 2 minus. There is nothing like odd or even. I just whatever I just say, just forget that. That is not the true. We need to consider only the greater thing, and greater thing is neutron here, though it is odd or even, that does not matter. But we have the 4 vacancy in the p 3 by 2 state, and 4 are filled, so 2 4 in 1 by 1 p 3 by 2. P 3 by 2 means 3 by 2 is equal to J equal to 3 by 2, and minus 1 whole to the power L means P equal to 1, so 3 by 2 minus only. Now are you clear?
Okay, ma'am. Yes, ma'am.
And whatever I was just telling about the odd even, that is some other thing that is not true for here. There here you need to calculate only the here you need to check only the greater thing. Which one is greater, neutron or proton? And neutron is greater. Neutron is 6. So 1 is half 2. 1 p 3 by 2 4. 3 by 2 minus 1.
Okay, ma'am. Yes, ma'am. Now I can understand. Thank you,
Okay,
ma'am.
okay, okay. Oh, I just got confused. Sorry, extremely sorry. So yeah, so that was the
It's okay.
thing. So I think now everyone can solve the ground state of any nucleus, and if after that whatever problem I have solved, you will also be able to understand that. If found any problem, then please ask as you are asking, and we'll again meet on the next day. And I hope this discussion session and problem solving sessions are helpful to you. So let's wrap up today's session, and goodbye to all of you. Meet next day.
Okay, ma'am. Thank you, ma'am.
All right.